Imagine leaving Earth on a spaceship, traveling through space for just a few years, and then returning home, only to discover that everyone you knew is older than you. Your friends, your family, even Earth itself. This is not science fiction. This is real physics. In fact, astronauts aboard the International Space Station are already traveling into the future right now. And the strangest part is that the deeper scientists studied time, the more terrifying reality became. Because according to modern physics, time is not constant. It can stretch, slow down, and almost stop. Near certain objects in space, 1 hour could equal years on Earth. Today we are diving deeper into time dilation than almost any astronomy video online. Not just the basics, but what time really is, how gravity bends it, why black holes distort it, how GPS satellites secretly prove Einstein right every day, and whether humans could one day travel thousands of years into the future. Right now, time probably feels normal to you. Second after second, minute after minute, it feels constant. Ancient scientists believed time worked like a giant invisible clock, controlling the universe equally everywhere. Even Isaac Newton believed time flowed identically for everyone. But Einstein discovered something shocking. Time is not universal. It depends on speed, gravity, and motion through space-time. That means two people can experience completely different amounts of time, even if they started together. This sounds impossible because humans evolved at extremely slow speeds compared to light. Our brains were never designed to notice relativistic effects. But the universe operates on rules far stranger than human intuition. To understand time dilation, we first need to understand one thing: the speed of light. Light moves at nearly 300,000 kilometers every second. Sunlight reaches Earth in about 8 minutes. Light is so fast that it could circle Earth more than 7 times in a single second. But here is the truly mind-breaking part. According to Einstein, the speed of light is always constant, no matter how fast you are moving. Imagine sitting inside a spaceship, traveling close to the speed of light. You turn on a flashlight. You might expect the light to move faster, because your spaceship is already moving. But it doesn't. Every observer still measures the light traveling at exactly the same speed. So if light cannot change speed, something else must change instead. Space and time themselves. The faster you move through space, the slower you move through time. As your speed approaches the speed of light, time slows dramatically for you compared to people on Earth. And scientists have tested this many times, with satellites, with airplanes, with atomic clocks, and with astronauts. Astronauts aboard the International Space Station orbit Earth at around 28,000 kilometers per hour. That speed is enough to create measurable time dilation. Their clocks move slightly slower than clocks on Earth. After long missions, astronauts have technically traveled tiny fractions of a second into the future. That may sound small, but it proves Einstein was correct. In 1971, scientists placed highly precise atomic clocks on airplanes flying around Earth. After the flights ended, the clocks no longer matched clocks on the ground. The moving clocks experienced time differently, exactly as Einstein predicted. Even GPS satellites must constantly correct for time dilation. Without relativity, GPS errors would grow by several kilometers every day. Every time you use maps on your phone, you are indirectly using Einstein's theory of relativity. But speed is only half the story. Gravity also bends time. Most people think gravity is simply a force pulling objects together. But Einstein discovered something much deeper. Gravity is actually the bending of space-time itself. Massive objects like planets and stars warp the fabric of reality around them. And time flows differently depending on how deep you are inside that distortion. The stronger the gravity, the slower time moves. Near Earth, the effect is tiny. Near neutron stars, it becomes enormous. Near black holes, reality itself begins to break. Imagine placing a heavy bowling ball on a stretched rubber sheet. Smaller balls nearby roll toward it. That is a simplified model of gravity, but in reality, time itself also sinks into that curve. A clock near a massive object ticks slower than a clock farther away. Scientists have measured this effect directly using atomic clocks placed at different heights on Earth. Even climbing a mountain changes how fast you move through time by a microscopic amount. Now we arrive at one of the strangest ideas in astronomy: black holes. Near a black hole, gravity becomes so extreme that time slows dramatically. An observer far away, watching someone fall toward a black hole, would see their clock slowing down more and more. Near the event horizon, time would appear almost frozen. Light from the falling person would become dimmer and redder, until they slowly fade from view. But for the person falling in, time would feel completely normal. This creates one of the weirdest truths in physics. Different observers can experience different realities. Near a supermassive black hole, time distortion could become enormous. In the movie Interstellar, 1 hour near the black hole Gargantua equaled 7 years on Earth. And surprisingly, that idea is scientifically possible. The calculations behind the movie were based on real physics. Extreme gravitational time dilation really could create massive jumps into the future. A person orbiting near a black hole for a short time might return to discover centuries had passed outside. That means the universe may already contain natural future time machines. Not machines made of metal, but regions of warped space-time itself. And now we reach the deepest question of all: what actually is time? Scientists still do not fully know. We measure time using motion: Earth rotating, atoms vibrating, pendulum swinging. But those are only ways of tracking change. Time itself remains mysterious. Some physicists believe time may not fundamentally exist at all. Others think the flow of time may be connected to entropy, the tendency for disorder to increase. A glass can shatter easily, but shattered pieces never naturally reassemble themselves. This direction from order toward disorder may create what we experience as the arrow of time. Strangely, most equations in physics work both forward and backward. But entropy gives time its apparent direction. Some interpretations of physics even suggest that past, present, and future may all exist simultaneously, like frames in a cosmic film, and consciousness moves through them moment by moment. No one knows if this is truly correct. But modern physics increasingly suggests that time is far stranger than humans ever imagined. Right now, you are traveling through time. Every second pushes you into the future. But the universe reveals something astonishing. Time is flexible. It bends under gravity, it stretches with speed, and it behaves differently across the cosmos. Astronauts already experience it. Satellites already correct for it. Black holes may distort it beyond imagination. And somewhere in the universe, there may be places where the future arrives faster than anywhere else. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." And the deeper humanity explores the cosmos, the more that illusion begins to break. If you enjoyed this journey through space-time, subscribe to Into the Cosmos for deeper astronomy and physics videos. Because the universe is far stranger than science fiction, and we have only just begun exploring it.